Hello, this is the code for Lab 2, the 7-segment display that's controlled by 4 switches on the FPGA. So I actually did this lab 2 different ways, and both work, although I'm showing off the second one today. The first approach is with an always statement, with a case statement for which I need this always. This is equivalent to saying always at bracket data comma segments, close bracket. But this saves me the trouble of typing out all the variables by hand, where I might make a mistake. So these values for 0 through 15 are copied from the hex table. And in the case statement, I always need a default. And although this never executes, this represents having all the bits be off because the 7-segment LEDs are active low. This is the way I actually ended up doing it. Same logic, but I assigned the output bit by bit, representing to whether showing that this segment turns on when the input is one of these 5 digits, and so on for all the other segments, and both work. However, in this lab, we also added a wrapper module to connect the 7-segment display to the physical switches on the board. This can be done by 2 ways. Either I assign data 0 through 3 and segments 0 through 6 in our constraint file, or I leave the constraint file as is, and I instantiate this in a wrapper module. And then I follow this up by writing a test bench. And then here's the results of my simulation. And to double check this is actually working, let's zoom in on, let's say when the input is 5, then the hex output should be 12. And well, by double checking here, we can see the output is 12. So these all match. Thank you. Hello, here's my programmed FPGA for Lab 2, which converts a 4-bit input to a 7-segment display output. So from right to left, these 4 switches will add 1, 2, 4, and 8 respectively to the output. And I'll just toggle them all from 0 to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15.